Hi, in this video we want to talk about trigonometric identities. Now there are quite a few of these identities and trust you will be provided with them on your information sheet, but you should be able to use these identities in order to simplify different expressions. So how do we actually apply these identities within an expression? So we're going to take just a simple example to show how useful this can be. And what we're going to take is cos of, or rather, let's say cos of 75. Now looking at it, we wouldn't think that cos of 75 is a special angle, because 75 was not on the list that we discussed. Cos 75 is something that's completely different. And without a calculator, how would we be able to solve such a question? So cos 75 is actually, or can be written down as cos of 30 plus cos of 45. Like that, cos of 30 plus 45 is similar to cos of 75. Then we recognize that what we've done now, this is a sum of identity, so, or a compound angle as they also refer to it. And we can apply this identity over here in order to try and solve for the question. What we are having is the addition of A and B, so A is 30, B is 45. What we get from this is cos is equal, or it's equal to cos of 30 multiplied by cos of 45 minus sine of 30 times sine of 45, like that. Then we can simplify this by now using our special angles. So cos of 30, if you refer to the previous lesson, that would be square root 3 over 2 multiplied by cos of 45, that would be 1 over root 2. Then we say minus sine of 30, that is 1 over 2 multiplied by sine of 45, that is 1 over root 2. Then over here we can factor out the 1 over root 2 from both terms, because we have this term and we have that term. So taking out 1 over root 2, we are left with square root 3 over 2 minus 1 over 2. And this, if we join it, will become root 3 minus 1 over 2. So root 3 minus 1 over 2, but now we can multiply with the square root 2 that's outside. So we're gonna get 2 square root 2, like that. And then this is our final expression. So we wouldn't have been able to get this expression if we had used the calculator, or if we had tried to use some other method. This is the only viable method that we are taught, and this is how you break down angles. Try to use special angles, or you can also use them when you are given the value of another angle. For example, given that sine 20 is equal to P, solve for tan of, let's say, 50. Then you have to recognize that, okay, I cannot combine any of the special angles to give me 50. Therefore, I need to combine a special angle, which is 30, plus the one that I'm actually given, which is 20. And then if you actually draw this out, this will be a triangle with angle 20 here, opposite side being P and that side being 1, and then you can find the missing side and solve for tan 30, or you won't actually solve for tan 30 because there's no identity for this one that we are taught at this point. So you'd have to convert this to sine 30 plus 20 all over cos of 30 plus 20. But as you can see, this will be easily solvable because we know what sine 20 is. Cos 20 is something that we can get should we use Pythagoras theorem to find the missing side. Then that is it for trigonometric identities.